hardware in there too, and NetBSD runs on these machines. Open firmware PowerPC is something else. You usually got these from Motorola themselves in form of the power stacks, and well, as there is support for PowerPC and NetBSD, the CPU, they're really off-the-shelf machines using standard I/O components, and doing this NetBSD port was pretty easy. The most important thing about the open firmware PowerPC port is, of course, the open firmware itself, which you can also find today in Sun machines or also in Power Macintosh machines. So it's some kind of BIOS. The next platform supported by NetBSD, PC532. This is a really rare machine. I think not much more than 10 of these machines exist today. They are for some homegrown CPU broker use the NF30K2K. They're really rare, but still, if someone has one and wants an operating system to support it, NetBSD is there as well. Yeah, again, PlayStation 2, you don't have to play games all the day. You can also use it for something useful, like running your own operating system for whatever kind of application you like. And NetBSD today also works on the PlayStation 2. For this to work, unfortunately, you need to buy the proprietary software from Sony, which includes the bootloader for alternative operating systems, which again includes also Linux. You just need that bootloader to boot NetBSD. You can throw away the Linux CD or use it as coaster if you want. Whatever. Also, the Linux kit from CPU for the PlayStation 2 contains a keyboard, which you probably want to use too for your true Unix experience. You don't want a mouse. What else? PMAX. Yeah, former Compaq, HP, Digital used to make some MIPS-based DAC stations. They were called workstations of the very first hours of Unix, or almost the very first hours. And they had MIPS-based CPUs, Casion boards, and fine graphics cards, and well, all the companies that own the rights to the hardware, or most of them aren't in business anymore. But if you still have some of them, you can use NetBSD as your operating system. That's a PMAX port. PMPPC is some rather new embedded type of PowerPC-based platform. I don't know, it's coming from some kind of manufacturer from Sweden. I don't know more about that. PowerPC is a generic PowerPC CPU support, and it's used among others then also in the prep based machines. Prep was when the PowerPC first came out, it was just a CPU, of course, and Motorola wanted it to be successful, so they said, there is Intel, which is a CPU too, but there is this very famous computer architecture that is using that Intel CPU, which is known as PC today. And it's using some kind of bus system, it has some kind of I/O control systems, and this is all public knowledge today, and if someone wants to build a PC, they can it because all of this is open today. And so Motorola said, we want to make someone able to build their own PowerPC-based machine too, and have to do that specification well. And the PREP, I don't know what it's spelled out, is the specification for a PowerPC-based computer, also with I/O components and things. If you have such a machine, there aren't many available. NetBSD is running on them. Next one, Sandpoint is some kind of PowerPC embedded board. It has a CPU, some RAM, I/O, via serial, and I think Ethernet. Not really common in everyday use, but of course NetBSD is available there. Also the SP MIPS, it's some embedded MIPS CPU computer. Something that's probably a bit more widespread in hardware use is the SGI MIPS port. Well, as the name says, this is for silicon graphics machines. Unfortunately, okay, so let's make this short. Yeah, there are a lot of machines from Spark and so on. People are complaining that it's boring. Let's move on. Sorry. I'd ask, where is this NetBSD thing? I don't see it today. There are quite a number of uses, and maybe let's just name a few companies that use NetBSD today. There is a Swedish company called Dynarc, or also from Japan, Root Incorporated, and probably a number of others. They build router hardware for internet traffic. Very important, not only IPv4, but also IPv6, which is very important in Japan and also growing in the United States and Europe. These companies use NetBSD today as it is available, and it's also available for embedded type of applications. One machine that's available, it's very funny, it's called Ipsio. It's a networked color copier printing fax machine, and for, well, processing of images and data and everything, it's using NetBSD as the operating system, so yeah. There were, some time ago, the idea to make thin clients available, and IBM was one of the companies to do such small machines, and yeah, they made two kinds of machines. One had a PowerPC CPU, the other had an Intel CPU, and they both had NetBSD as the operating system, sold by IBM. Of course, they are not telling you this in many parts of the documentation, but there are parts. The same company then that still existed was Digital. They made some network computing specs, and as some kind of proof of concept operating system, they used NetBSD, again, as it was available and portable to the CPU architecture then, which is ARM based. Yeah, one very funny platform that NetBSD is also used, but not exclusively, is the International Space Station. So this is the answer to how many NetBSD computers are there on this planet. This also contains how many are there not on this planet. So the International Space Station has some experiments running, which are running on the NetBSD operating system. The hardware-software combination is designed to be running for about 10 years. I then asked them for an account to turn it in and check the uptime, but they couldn't give me one. And of course, well, NetBSD is just a Unix type operating system, which you can use for everything you use other Unix types, Linux, Solaris, don't know today. So you can build any number of servers and desktop machines, and I do not have estimations for a number of that, but it's obviously available. Yeah, of course NetBSD is also secure. Yeah. Some people think security is not important, others think security is the only thing you have to worry about. For NetBSD, security is something that doesn't need special mentioning, because of course we do care about security, and yeah, everything that you need is available. NetBSD has integrated firewall toolkit. It's using Darren Reed's IP filter package. The OpenBSD PF is also available as patch kit, and if you prefer that, there's some way to get into that too. Usually IP filter works as firewalling kit very well. If you want cryptographic software for some kinds, IPsec is available thanks to the CAIM project. Kerberos 4 and 5 are available. OpenSSL, in usually the latest form, less bugs, are available. And OpenSSL, of course, is then used for the OpenSSH secure shell server, which comes out of the box with NetBSD. So if you don't trust Telnet, which you shouldn't, it's there. Something that also comes up quite a lot with in the context of securing or making an operating system more secure is code audits. Of course, NetBSD is doing code audits too, but we have very little developers with even less time on their hands. And if there is some known type of attack, The usual way in NetBSD is not to some special kind of printf or something, or strcpy calls. The usual thing in NetBSD is to modify the compiler and make it recognize dangerous constructs automatically and warn about it. This was done, for example, for printf format string attacks, if someone knows technical details. So this is some automated form of code audits. Of course, there are still manual ones too. Other security feature from NetBSD, system information are published via some interface, usually using sysctl calls, and this is to replace set user ID binaries which have all the rights in the kernel memory to read or write anything, change anything, which is usually used for buffer overflows, and NetBSD just prevents that this way. Yeah, and it's just interesting, maybe too, NetBSD has the least number of incidents reported on Bugtrack. If you just compare number of incidents over operating system, that's the fact. Of course, you can ask now, well, no one's using NetBSD today, so no incidents reported. I can prove that this is not true. Okay. When going to some mixed kind of people that I don't really know what they have as background, I usually hear two questions. The first one is, what is the difference between Linux and, well, some kind of BSD, or between Linux and NetBSD? I could give you some technical information now. I don't think that will cut it. Instead, I would like to think in a bigger picture. Linux is not all the world. From the list of architectures of supported hardware that I went into initially, you have a picture that there is more than just a PC hardware out there. And you might think that there is also more than Windows out there, thanks God. An operating system or type of operating system that's available on many on these machines out of the box, it's what's called Unix. Unix isn't really an operating system that you can't buy anywhere. This is like from Leningrad Cowboys, the guy that walks into a shop and a record shop and asks, do you have rock and roll? Can I buy it? You can't buy rock and roll. You can buy some rock and roll band or a record or CD or whatever, but you can't buy rock and roll, and it's about the same with Unix today. Every vendor of the special hardware has some kind of operating system. Some operating systems run on more than one hardware, others don't. So this is all just Unix. FreeBSD, NetBSD2, OpenBSD, BSDI, Solaris, SCO Unix, HP Unix, Digital Unix, AIX are just a very small number of Unix-like operating systems today. And all these used to exist long before Windows was even born. So this is just to give you an overview of the picture. Of course, with that many Unix dialects out there, this is a problem because it's confusing to people. The situation right now in, let's say, the business world is there is Windows. You can't deny it. Everyone hates it, so who doesn't wish to have an alternative to Windows? The media has crowned their king, and they choose Linux to be the alternative to Windows. Not any of the existing Unix type systems that I mentioned. They choose Linux for some reason. And of course they're ignoring a few things like there is no Linux operating system too. There's Linux distributions. Linux is just a kernel. And to have a full operating system, you need more than that. You need an installer, you need some editor, you need something to print things. And all these things are arranged in what's called distributions. And yeah, for NetBSD or BSD in general, they are whole operating systems containing not only the kernel itself that manages hardware, but also a set of tools like editors, compilers, and so on. a small base of applications, usually including the X-Windows System 2. The main difference that you might see between Linux and BSD, or take any Linux distribution, is you usually have all the application software that you have from Linux, at least on the PC platform, of course. If you go to some non-PC platform or in the embedded environment, you usually have a problem anyways. And there, NetBSD in this special case still has all the software available by compiling from source. And of course, the kernel is different. It has different set of features, supported CPUs, supported drivers, etc. You can check this out on the current feature list. I don't want to go into that. So this is just a different kind of view. The next question that people ask a lot is, what is the difference between the various BSDs? There's FreeBSD, there's OpenBSD, there's NetBSD, there are a few more. What's it? Again, if you want an answer to this question, please pick the feature lists of each of these operating systems and compare them. You can get each of the major BSD flavors today for free and install it. Check this out for yourself. I would like to go into some historic kind of comparison. Like, give you a few idea of how this whole BSD thing evolved. BSD stands for Berkeley System Distribution, which started at the University of California at Berkeley around 1979, and they made their own Unix distribution, the Berkeley System Distribution. A small set of Unix which had some tools like a Pascal compiler, C compiler, then editor, the visual editor VI came to the Unix then. And well, the university sponsored the project, but at some point in 1985 or so, they said, okay, we don't have any money anymore, we have to stop that project. Of course, a lot of people then were using the BSD operating system. Not only people, but also commercial companies used BSD to place their products on it. SunOS from Sun Microsystems is just one example. Ultrix from Digital then, I think HPUX also used some parts. All these companies also use the BSD system. Well, many of the companies started developing the system for their own, of course. BSD, as it was always free, wanted to remain free, and well, basically two projects emerged. The first one was FreeBSD, which said, okay, right now you have to look at what BSD was then. It was a Unix operating system which supported compilers, typesetting, text processing, and so on. And it supported a small set of hardware architectures. PC was very new then. It was supported SPARC, HP, VAX, of course, and some others. I forgot. All these machines were supported by the BSD operating system then. And well, there were basically two groups of people. The ones coming from the home PC crowd said, we have a PC at home and we want this BSD thing to run on our PCs. This is basically what FreeBSD went into. They said, okay, we want to focus on the PC platform, support all the latest features, drivers, obscure hardware that's found in today's PC market. And this is where FreeBSD is quite good at. Then there were other people who said, I have some HP machine at home, I have a few old Suns and so on, and I want to use an operating system, and if possible, I want to use the same operating system on all machines as I was used to do with the BSD system. Well, and this is what emerged into NetBSD. A multi-platform operating system that provides the same operating system functionality on all hardware platforms, not regarding the hardware. So these two projects split from native BSD. Later at some point in about 1995 or so, there were some personal problems between a few NetBSD people, And the result was, what's called OpenBSD 1.1. It was really just taking what NetBSD was then and the string OpenBSD, and this was OpenBSD release 1.0 as far as I remember. Of course, if you start such a very big project, you have to find some catchy slogan, and the focus of this project that Theodore made was to do security, make the operating system more secure, and this is also what its main selling point today, more security. Well, this is how it is, and if you see it in the historical context, this may give you also some idea what's happening in the various BSD counts, like FreeBSD, PC stuff, NetBSD, everything else, OpenBSD security things, nothing else, and t-shirts. So maybe view it from the historical section. Of course, people come a lot to me and ask, what operating system of the three would you install? Well, I can give them an answer, but it's really biased. I am a NetBSD developer. I've been using NetBSD since 1993, and well, usually, of course, I recommend NetBSD. But if you have something that really wants SMP on PC, to get some high-performance servers for web or database or anything, and if you want to use SMP servers for PC hardware, then my recommendation is today still use FreeBSD. There's some works on NetBSD with regard to SMP, and it will be available in the next release. But right now, FreeBSD is still predominant in this market. OpenBSD, from my point of view, is a very secure operating system, just as every Unix operating system is if the administrator knows what to do. OpenBSD still have a few features that I found unique in it, and which is like OpenBSD supports a lot of crypto hardware drivers. Like if you have some kind of network cards that do IPsec in hardware, they are usually found supported in OpenBSD and not in many other places. Also, one very cool feature, OpenBSD has the firewalling module doesn't only work on ISO layer 3, which is IP, but it also can operate on ISO layer 2, which is Ethernet. So if you want to implement a filtering bridge, this can be done very easily with OpenBSD. I think it will be available in NetBSD soon. It's not really hard to implement, but it seems nobody really bothered to do it. With today's waveline business, this will change very soon. So this is our two very special kind of supports, and you might want to check that out. For everything else, well, I recommend NetBSD. Try it out; it's free. For going into the details of the NetBSD operating system itself, there are basically three components. The base system itself, of course, consists of the kernel, but it's also a set of small userland utilities, network services, of course, a C compiler, C++ compiler, and so on. So you have a very small but usable Unix operating system. Unix operating system is traditionally ASCII-based stuff. If you want GUI stuff, the X3 or Xwindow system using the X3 project's code is available in NetBSD for a lot of hardware platforms, not only PC. And NetBSD really just adjusts what X3 is doing and hands this out with the operating system. Now, of course, this doesn't really cut it. You still want a lot of other software. You want to maybe to do a database server, do a web server, make some desktop machine, or make some firewall or whatever, and you have to install software for that. And all this software is available in NetBSD's package collection, which is available with NetBSD. which it can be compiled either from source or installed from binary package. And right now there are more than 3,000 software packages available in NetBSD 1.6. So you can install on the system whatever you like. And examples just for looking into things. You have to make a difference between updating a component of the system or updating one of the packages. There is this annoying difference, but still it's not that bad. Let's look at this example. It's not really difficult, and it's handling the cause. What's happening if there is another hole in the open secure shell server or client which is used by NetBSD? Well, if you want to update your secure shell, you change it into the user source directory. This assumes you have sources installed, of course. And then you usually just type CVS update to get the latest sources for the whole operating system. Then you step into the user bin directory SSH. This is where the sources for SSH, client and server, and some support programs live. Using make, you compile them, compile the latest sources. And after switching to super user, you just type make install and everything is updated. No more security hosts. Of course, the daemon has to be restarted. That's not depicted here. So no cryptic fetching of disk files or something, yes? No, right now there's no patch system available for binary patches. You have to do that from source right now. As an alternative, you can use software from the third-party packages collection, which usually is located in user package sources for packages, and type CVS update there too. Then let's say you want to update your Mozilla because it has been found yet another security problem. You change to the www/Mozilla directory. And this directory contains some build instructions on how to build Mozilla. And you then just tell the system, please make it so. Nothing else. If you haven't installed Mozilla yet, this will install all the required components for it first, libraries, whatever. And then fetch also Mozilla sources, unpack them, compile them. Next point is when you're upgrading, you can make deinstall to remove the old installed Mozilla. And if you then type make install, the newly compiled one will be installed. So this is basically the update process. If you want to blow away the sources, you can do that with make clean. Yeah, unfortunately, I'm running out of time right now. NetBSD in embedded environments. It's very popular already. It's becoming more important right now and in the near future. Why? NetBSD has support for a lot of CPU architectures. This is important because Intel just doesn't cut it in small places because they use too much power. You have to use another kind of CPU today, and there are several available which consume very little power. Especially ARM, MIPS, PowerPC, Xscale, and Super Hitachi 345 are used in embedded environments today, and these CPUs are supported by the NetBSD operating system. This means support by the operating system means, first, the tool chain also supports cross-compiling. You have an installed NetBSD system that's running on a PC or something, and you have this pile of hardware that doesn't run anything. So you can't use NetBSD to compile itself on that machine because there is no operating system on it. So you have to do some kind of cross-compiling. The toolchain that's available in NetBSD 1.6 has full cross-compiler support, and you can say, okay, I want to make a cross-compiler for this and that platform including CPU information and some other things. Of course, then the kernel can be cross-compiled easily. Kernel itself is only one thing. Then you need more than that. The whole operating system, the whole NetBSD operating system, user lands with sort of tools, can be cross-compiled easily too. And if that is done, distribution media can be made easily for installing it. This is like done for the NetBSD 1.6 release. It was all cross-compiled on a very fast PC, and it installed CDs for VAX, and everything were really made by cross-compiling. You can fast PC like doing it in 2 hours. This is of course easy to do still if you have NetBSD running on your VAX. If you're doing development for some embedded platforms, it's not so easily, and this is why cross-compiling is so important. Yeah, give a very few overview of how to do it. How do you build a cross-compile for SGI MIPS? If you have some silicon graphics machine, it's not really the fastest, and you want a cross-compiler that builds binaries for SGI machines using NetBSD. NetBSD has a very interesting command starting with 1.6, and it's called build.sh. It's a shell script, and using this script you basically manage the whole compiling environment for NetBSD. We are using 2 switches here, -T and -M. -T just says, please just compile the tool chain, nothing else. Build me a compiler, and well, I have to tell the system what target platform we have. This is done with the -M switch. Please build me a tool chain for the SGI platform. This takes some time, and after that, DLS output here gives a small list of tools compiled. It's not only the C compiler, also Make and some other things are compiled to make cross-compiling easily. This is needed for when cross-compiling the whole NetBSD operating system. Yeah, compiling a kernel itself, if you're familiar with BSD compiling, it's basically 2 commands. You use the config command, which is renamed a bit here in the cross-compiler environment. Use the config program and a config file using generic here as a file name, and then set up for kernel compile is generated. After that, you just run the make program in a special directory using depend and all as arguments. And after some more chewing on the CPU, this spits out a kernel which you can then boot on the target platform. In this example, it will be a working SGI MIPS kernel for NetBSD. You can run this on any platform running NetBSD, like PC or whatever. If you want to cross-compile the whole operating system, not only the kernel, you have to just give it a few more switches. Don't give it -T because you don't just want the tool chain, you want the full cake. -M SGI MIPS says, I want to do platform SGI MIPS. -D says, I want to do a full distribution. And then give it 2 directories. One to -big D, uppercase D. This is a place where the whole system will be installed for a temporary case, not for running, just for installing things. And -uppercase R. This is where distribution media will end up. So this is, yeah, places that CD images and everything will be placed, or floppy images. Yeah, this was a very short course through the NetBSD operating system and where to use it and how to use it, what the differences between various BSDs are. Also a little introduction to the cross-compiling and embedded feature set. Unfortunately, time's running out now, so you might ask the question where to get NetBSD. Of course, there's the obvious web address. If you want to get the latest release, it's available from FTP NetBSD, or you also can use anonymous CVS for NetBSD. And if you say, okay, I don't have net access or something, you can also buy CDs from various vendors and bookstores like Lehman's. They're usually selling Wasabi CDs or something. We also have CDs here at the booth. So if you have any more questions right now, I don't know how much time we still have, or later, feel free to drop by at the NetBSD booth in the Hack Center at the entrance in the lower left. We have a booth there with lots of machines to view, and, well, just drop by and see what NetBeastie looks like in full operation. Okay, I think that's everything for me now. Thank you very much for your attention, and if there are a few questions right now, I don't know how much time do we have, none at all, so please come to the booth later.